make sure the selection
Okay.
is like yesterday so that the my camera is on the left side and the slides are on the right.
Yeah. Okay. Okay. Yeah. Okay. Yeah. So hi. Good evening, everybody. And welcome back to TezAsia Hackathon. So for today, we will be building a dapp on Tezos in SmartPy. This is the first part. I would like to introduce you Hanchu. So he's a smart contract engineer from Tesla. So without further ado, I would like Hanchu to to take over. Yeah, thank you. Let me
Thank you,
start
Brian.
this.
A very good evening to everyone here. So this is the first hands-on workshop for Tezos smart contracts for you all. So today I'll give you a quick primer on Tezos, and then we will write a basic smart contract in SmartPy. So basically, the next three sessions are grouped into one. So today is the first part of that, where I'll give just walk you through the basics of SmartPy and smart contracts on Tezos. Tomorrow we will write a full-fledged lottery contract. Basically, it's a lottery game following the best practices, and then even deploy it on the testnet. And finally, in the third session, which is, I guess, on Saturday, I will teach you how to build a front end in React.js and then connect it to the lottery contract that we deploy tomorrow. So just remember that all of these three workshops are interconnected. So you must be a part of all of them if you want to get a proper hang of how to build a complete end-to-end app on Tezos. So just like yesterday, I would request you to bookmark this link, because on this link, I will be posting the slides and the video recording and also any relevant code and reading material that you would be needing for the sessions. So please bookmark this. And Brian, maybe you can send this on the YouTube chat once again. Brian?
Yes. So I will
Yeah.
share both of the links.
Yeah.
Both the Discord link and the GitHub link inside into the YouTube chat. Just find it there
Mhm.
for you guys. Yeah. Thank you.
Yep. So, so yesterday we learned about blockchains in general, and Tezos is also one of the blockchains. But we really need to know why exactly are we building on Tezos and how is it different from other blockchains. And to understand that, first we need to explore the problems with existing blockchains. And one of the biggest problem with existing blockchains is that it's really difficult to upgrade the blockchain. So let's say in the case of Bitcoin, it's a proof of work chain. And as you know that in a blockchain, we have several nodes. So upgrading is very difficult because all the nodes have to upgrade their software in one go. And there is no proper sequence to achieve that. So usually what happens when an upgrade is scheduled is that some nodes in the network upgrade their software, some choose not to, and some just don't bother to. And what really happens is there is a fork in the chain. And by fork, what I mean is that the nodes that do not upgrade their software, they keep building blocks on the old chain, and the new nodes, or the nodes with the new software, they have their own chain with the new set of rules. And in Bitcoin, this has happened notably thrice. So first, the orange one is the actual Bitcoin that you know. And the first major fork was the Bitcoin Cash fork, where there was a change in the block size. So the block size was increased from 1 MB, and half of the nodes didn't choose to increase it. And there was the first fork. And then this is the second fork, which is also known as Bitcoin SV. SV stands for Satoshi Vision. And in this Bitcoin fork, the throughput of the chain was increased. By throughput, it's basically the number of transactions that the chain can process every second. So that was scheduled to be increased. And once again, we had a fork. So right now, if you go ahead and you check on some website like CoinMarketCap, you will see three versions of Bitcoin. The original Bitcoin right at the top, then you will see Bitcoin Cash, and then down in the list, you will also see Bitcoin SV. Now, this is definitely not ideal, right? Why should we fork the chain every time we need to upgrade it? And you will also know about the whole Ethereum merge drama, that there was this prediction that when Ethereum POW Ethereum merges with POS Ethereum, and we get Ethereum to everything, would seem everything might collapse and the chain might break. Well, it's okay. It happened okay in a perfect way on testnet just a few days ago, but let's see what happens on mainnet. So long story short, on Tezos, if you want to upgrade, you can do it in flight because Tezos is a POS blockchain that can evolve. And recently, Tezos had one of the biggest upgrades ever, where the entire consensus mechanism of Tezos was changed. So originally, we had a Nakamoto style consensus, which is the consensus we have on Ethereum and Bitcoin and some other old chains, where you're not sure when will a transaction get confirmed, and you can't have a rollback in the transactions. And we changed that consensus to a more modernized BFT consensus, where in just 2 blocks you will be assured that your transaction is confirmed and there won't be any kind of a reorg or rollback in the chain. So this was an in-flight protocol upgrade. So at 1 block we had a completely different protocol, and on another block we had a different protocol, and this is just incredible. And this is why we build on Tezos, because of this major feature. So Tezos has had quite a lot of upgrades, 10 in total, and in the next month we will be starting off with the 11th upgrade. So as you can see, all these upgrades are named after ancient and existing cities. We started with Athens, and right now we are on the Jakarta protocol. So I've mentioned the changes that were brought about on the protocols. And as you can see, in the Ithaca upgrade, we got the DFT consensus. And in the latest upgrade, which is the Jakarta upgrade, we got transaction rollups. And this is also something really incredible, because on other chains like Ethereum, rollups are usually done by third parties. They have their own contracts for rollups. But on Tezos, we have rollups enshrined or built into the protocol. And that is what we got on Jakarta upgrade. So this is truly incredible. Now you must be wondering, like, how does this upgrade takes place? Like, okay, on 1 block we have some other protocol, and some on the next block we have some other protocol, but how does this happen? So this doesn't happen very haphazardly. Rather, we have a proper sequence of steps. So first we have a proposal period. Now in the proposal period on Tezos, we have entities or validators who are also called bakers. I'll get to bakers later on. So these validators, what they do is they inject proposals into the network, and these are upgrade proposals. So basically, there is an upgradation to the existing code that is proposed. So let's say we have like a few proposals in the system. Then in proposal phase, the bakers vote to just choose one of the several proposals to go further. So the proposal that goes further, that goes into the exploration period. Now, in the exploration period is more like a confirmation period, where the bakers vote yes or no, or just abstain from voting, and they just confirm whether they really want for this proposal to go through. And if a proposal passes the exploration period, we get the cooldown period, where it's just as it sounds, it's a cooldown period where nothing really happens on the chain, but behind the scenes we are testing the protocol. We are stress testing everything, and whether everything is good with the code. And if everything is good, then in the promotion period we have the final set of voting, and we promote the protocol to be integrated with the chain in flight. And then we have the adoption period, which is just like a brief time span, where the nodes are requested to upgrade their software so that they can build blocks on the new protocol. So this whole process takes about 3 months, give or take. And in 3 months, we have a protocol upgrade on Tezos. So this is truly, truly incredible. So apart from the normal consensus model that I spoke about yesterday, like POW and POS, on Tezos, we actually have a special variant of the latter, which is called liquid proof of stake. So let's say you are just a normal user, you're not a node or a validator, and you have like a whole lot of Tez sitting in your wallet. Now, what would you do with this Tez? Because it's just sitting there. You can really put it to use. So on Tezos, what you can do is you can delegate this Tez to a baker. The baker is once again a validator. So this is a snapshot from TZKT. I gave a brief tutorial of TZKT yesterday. So as you can see, this account has delegated to Everstake, which is a Tezos bakery. And the main advantage of delegating is that this validator will further use your tokens delegated to them to increase their stake in the protocol. And what really happens when they increase their stake, they get more chances to bake blocks or to make blocks on the system. That is, they get more rewards as a result of that. And if they get more rewards, what they do is they share the rewards with you. So as you can see here, every 3 days, the baker is giving rewards to the person who has delegated the tokens to them. So this is what we call baker rewards on Tezos, and ideally you get them every 3 days if you stake your tokens with a baker, if you delegate your tokens to a baker. Now, why is it called liquid? It's called liquid because when you are delegating your tokens, you're not losing the ownership of your tokens. Rather, the network takes snapshots of the balance delegated to the bakers, and using that snapshot, the final stake is taken by the network. So that's why it's called liquid, because you can still move your tokens around. And most of the protocols most of the blockchains right now are trying to get a liquid version of proof of stake, because on their blockchains you have to completely lock up your tokens if you want to delegate them. Like on Polygon, you have to lock it up, and that is not ideal. You should ideally be able to move it around, right? So this is another great feature of Tezos. So some of the most used terms on Tezos, I have already used a few of them. So first is the baker. So on Tezos, a staked validator is called a baker, which is similar to a miner on Bitcoin or Ethereum. And a level is just an alternative name for a block. Tez with a small t is the unit of currency on Tezos. So just like on Bitcoin, we have BTC, on Ethereum, we have ETH, on Tezos, we have Tez. And mutez is a smaller version of Tez. So one Tez equals 10 to the power of 6 mutez, or 1 and 6 zeros. On Ethereum, we have Wei. So just like one Wei is like one ETH is 10 to the power of 18 Wei. And on Bitcoin, we have Satoshis, which is a smaller version of BTC. And finally, we have XTZ. Now, XTZ is nothing but a ticker symbol. Most of the time, you use Tez, and XTZ is what you'll be seeing on something like exchanges. So it's just a ticker symbol, just like BTC for Bitcoin and ETH for Ethereum. We have XTZ for Tezos. Before going further, any questions, Brian?
Hi guys, I don't see any questions from you, so please, if you could, you can leave it in the comments here. I think for Pancho, you can move on. There's no more questions actually. Yeah.
Awesome. So right now we learned about the protocol upgrades that can happen on Tezos and also the liquid proof of stake. So these are two great advantages. And finally, the third advantage, well, we'll get to the third advantage, but let's explore the problem first. So another problem with smart contract chains is that the final code that actually runs on the nodes or runs on the interpreter is a really low level code. So what you see on the screen is something called EVM bytecode, or Ethereum virtual machine bytecode, which is eventually fed to the Ethereum virtual machine. So all the smart contracts that you end up writing in Solidity or Viper or any language that is supported on Ethereum, that gets eventually compiled down to these numbers, which is an unreadable form of code. Now you would ask, like, what is the problem with this? Because you still can write in a high level language, right? Well, the problem is that, let's say if the code is not open sourced, then this is what you will be seeing on a block explorer. And you really can't make anything out of this. Like, what exactly the code, like, what is the code all about? How can I know what is happening with the money that I'm sending to the code? So this is definitely not ideal. Now, Tezos changes that with something called Michelson smart contract language. Now, Michelson is a sort of a high level language, And as you can see, this looks something like assembly, but you can see we have types here. So this is slightly higher level. So the one thing that it offers is better readability. You can figure out what's going to happen with the money you send to the contract. Secondly, it is strongly typed. So you can see we actually have integers being used here. We just don't let the machine figure out whether 2 is an integer or some other type. We actually explicitly mention it. And third, it's ease of formal verification. So formal verification is actually a technique where mathematical models are used to prove the correctness of the code. So the way Michelson is structured, formal verification is really, really easy. And obviously, this is not possible on something like this. Like, what mathematical model will you put on just these bunch of numbers, right? But here you can do that. And finally, this is not an advantage, but this is a feature. And that is, you don't really have to write code in Michelson, because obviously it's going to take a lot of time if you want to write a very complex code. Rather, you write code in even higher level languages, like we have SmartPy and Lego on Tezos, and you end up writing the contracts in them, and they compile down to Michelson. So just like I mentioned, we have SmartPy and Lego on Tezos. There's another language called Archetype, but these are the most popular ones. So as you can see on Lego, it's something called functional programming. So this is a bit complex for those who are just starting off. So for them, we will be taking the SmartPy workshop today. We will eventually be having a Lego workshop too. I guess it's towards the end of the week. But for me, I will be giving you the contracts in SmartPy. So SmartPy is basically a Python library where you write code in normal Python, and then it compiles down to the Michelson language, which is further fed to the interpreter of Tezos. So what is the structure of Tezos smart contracts? Well, on the left-hand side, I have a very generic object-oriented programming class. So here you can see we have a class block, and inside that we have a constructor block. And what do we do in the constructor block? Well, we define member variables, right? And then we have a bunch of functions. And what can you do in the functions? You can use or modify these member variables, right? So this is how a generic class is structured. And this is like very JavaScript-ish, right? We have a constructor and function. And these are also the keywords used in JavaScript. Now on the right, I have a structure of a Tezos smart contract. Now first we have a contract block. Within that we have a storage block. Now in the storage block, what do? We define state variables. These state variables can be compared to member variables. And then we have entry points. Now these entry points are just an alternative name for functions. And what do these entry points do? Well, they can use and modify the state variables. So you can see both of these are very comparable, and it's very intuitive to understand how a smart contract is actually structured. So on SmartPy, what the kind of programming that we do, it's actually called meta programming. And this is code writing more code. Okay. So what really happens is that we have a SmartPy code, and the SmartPy code that you write first gets compiled to SmartML, which is like an intermediate language. And SmartML then further compiles down to Michelson. So this is a process where you write one code which gets to some other code, and then this goes to some other code. So that's why writing code that writes code, that's metaprogramming. And to achieve this, SmartPy needs to do two things, two really important things. And the first is that the existing Python constructions are overloaded. So let's say we have if, else, for, while, and other existing constructions. They are overloaded, and what we get in SmartPy and what we have to use is sp.if, sp.else, and sp.for. And for while, we'll have sp.while. So these are overloaded constructions. And for the functions, so first we write functions as general Python functions, and we use function decorators on top of them to tell SmartPy that this is an entry point and this is not a generic Python function. So for today, we'll just be focusing on SmartPy. You don't really have to worry about SmartML or Michelson. even though I will show you what Michelson looks like, but our main focus will just be SmartPy language. So let's write a contract. But before that, Brian, maybe if there are any questions.
Yeah, okay. So a question would be, is it similar to assembly code? One of the users has actually posted this. Is it
Okay.
assembly language? Yeah.
It's actually high, so assembly is like very low level, and what we will be writing like SmartPy, that is like really high level. But as you can see here, Michelson, this sits somewhere in the middle, because in assembly you don't really end up passing strong types. In Michelson, as you can see, we pass integers, and you can also use other types like strings and booleans. So you can't call it assembly, but it's somewhere in the middle of a very high level language and very low level assembly code.
Okay. There's another question. So, a user has said Michelson language is like Ethereum's bit code, but more readable? Question mark. Yeah.
Yes, exactly. So it's called opcodes. On Ethereum, we have opcodes, but opcodes are very low level, because in opcodes we have statements like jump statements. So at one point you are in the control, somewhere in the control flow, and the next point you just change it to some other position, which is very hard to understand. So that doesn't happen in Michelson.
Okay, one more last question.
Mhm.
So another question is, why don't we directly code in Smart ML?
Well, we can definitely do that, but it's not ideal. So like if you see Lego, Lego is actually a functional language, and for Lego, we don't have many intermediaries like we have on SmartPy. But then again, you can see Lego code, how it actually looks like. It's not very ideal for beginners, and that is the main reason we don't choose Smart ML. Rather, we have a better, higher level, a more higher level language, SmartPy.
Yeah, okay. I think that's the last of the questions. You can move on. Thank you.
Awesome. So let's write a smart contract. For that, please go to smartpy.io/IDE. Brad, maybe you can paste this link in the chat box. And today I would recommend that just look at what I'm doing. You can you can write the contract simultaneously on your machine, but what you can do is just understand what I'm trying to do here, and then when you get the recording, you can follow through once again. So I'll go to the SmartPy editor, and I'll click on create contract. And for today, I'll call it playground, because I'll just play around with some of the types and some of the features of SmartPy. Now, the first thing that you do when you start writing a SmartPy program is you have to import the SmartPy library, right? So we import SmartPy as SP. SP is basically the alias that we will use to refer to the functionalities or constants or other items provided by the SmartPy library. And then we write a generic Python class, let's call it playground. And then we inherit from the sp.contract class. Now, this actually tells Python that this is not a general Python class, but rather this is a SmartPy or a Tezos contract, and we have to handle this differently. Now, just like in a standard Python class, we have the init function, which is like a constructor. We write the init function, and within init function, we write self.init. Now, you don't have to really try to understand that why is it self.init and why not something else, because this is just standard stuff that you do for every contract. And self is basically equivalent to this keyword in other object-oriented languages. So what do we really do with this self.init? Well, this is the storage block. The storage and the state variables of the contract will be defined in this block. So before defining the variables, let's take a look at the types that we have. Just confirming, Brian, is the slide common Michelson types visible? Brian?
Sorry. Yeah. This
Okay.
this slide is visible. Yeah.
It's
You
common
can
Michelson types, right? Yeah.
yeah, common
Okay.
Microsoft types. Yeah.
Okay,
Thank you.
awesome.
Yeah.
So we actually have some types in Michelson, and then we have SmartPy equivalent types of those types. So in Michelson, the first type that we have is the nat type, which represents any number greater than or equal to zero. And on SmartPy, whenever you are representing a Michelson type, what we usually do is we write SP dot a capital T and then the type with an upper starting with an uppercase letter. So nat is represented as sp.tnat. Then we have literals. So if you have a certain literal and you want to force it to be of a certain value, then you can wrap it around sp dot then the name of the type. So if you want a number to be a nat type, then you can just do sp.nat, and within the parameters you can pass 5. Then we also have integers. And for integers, we can do the same like we do for nats. We can do sp.int5. Then we have the address type. Now, address type actually represents normal Tezos addresses. So that can be a user address, which usually starts with TZ1 or TZ2 or TZ3. And it can also represent contract addresses that start with KT1. Then we have timestamps. Now, if you come from maybe Ethereum background, you would know that on Ethereum, timestamps are just of the usual integer types. We don't have a separate type for timestamps, but on Tezos, it's really strongly typed. So we also have a timestamp type. And for timestamp, if you want to just use a specific timestamp, you use the timestamp literal. But most of the time when you are using a timestamp, it's the Unix timestamp at which the block is created. So we'll get to that. Then we have maps and big maps, and I'll come to maps and big maps later on. Then we have mutez. Now, mutez is the type of the native currency on Tezos. Now, the native currency is actually Tez and mutez both, and mutez is the smaller version. But in Michelson, we don't have Tez. It's all in mutez. So let's say if you want to use two Tez, then you can either do sp.mutez 2 and followed by 6 zeros, because one Tez is 1 to 10 to the power of 6 mutez. So you can do this, or you can just do sp.test2. But the thing to note here is that it doesn't matter which one you use. In the base or in Michelson, it will always be mutez. There is no such thing as just Tez in Michelson. Then we have the pair type. Now this pair type, you can compare it to the C++ pairs, where you will combine two variables of either the same type or different types. So here you can see I've made a pair where the first item is a nat and the second item is an integer. Then we have list type, which are just arrays. And this is how you can define a list. We basically first define the initial value and then the type of the elements that are present in the list. Any questions that you want to say?
So I think there is a questions.
Yeah.
What is a map and what is a net?
Sorry?
I think yeah. So you go back to types. One or two of the questions are like, what is a net, NAT, and what is a map? Yeah,
What is a map?
yeah. I think it means if you look at the column 6, I think map. Yeah, a user is asking on what is a map. What does a map mean? Yeah.
Okay, yeah, so that's what I'm getting to. So map versus big maps.
Oh,
So
okay.
maps are, you can compare maps to something like Python dictionaries where you have key value pairs. Okay, so that's why in Python the dictionaries are represented through curly braces. And these are just key value pairs. The key is of certain type and the values can be of a certain type. And for that we have maps and big maps on Tezos. And what is the difference between them? So the main difference is that maps, in the case of maps, the entire map is always loaded whenever we are trying to access it. What that means is that, let's say we have a map with 5 values, 5 keys and 5 values, and we also have a big map with 5 keys and 5 values. Then in the case of maps, if we are trying to just access one key, then the entire map will be loaded. When we are just trying to access one key, all the 5 keys and their values will be loaded. But in the case of big map, it's something called lazy deserialization, or you can also compare it with lazy loading. So what really happens is that if we are picking out just one key, then only that key value pair is loaded. It's not the entire big map that is loaded onto the the operation stack. That is what we call it. So the advantage here is that with maps, even though all the values are loaded, but we can iterate through a map, and we can iterate through the map because we have all the values, right? But in the case of big maps, we can't iterate through. So that's why you can use them accordingly. If you want iteration, you use maps. If you do not want iterations, but you have like a large number of values to store, then you use big maps, because it is really ideal for large number of values, because you don't want the entire set to get loaded onto the stack, right? That's very heavy, and you will end up paying more gas fees for that. So
Okay.
yeah.
I think. Oh, sure. Yeah. I think there's another question. What is a
Mhm.
net? Yeah.
What
NAT.
is NAT? Is actually, it represents a type that is greater than or equal to 0. So let's say if here I put any value from 0 to any value, positive value greater than or equal to 0, then that would be a NAT. But for integers, it is all integer. It can go from 0 to the positive end and also to the negative end. So -5, -4, all of these can fit into integers. But for NAT, we just have positive values greater than or equal to 0. I guess that should answer your question.
Okay. There's no more questions from the
Mhm.
audience. Yeah.
Yeah.
We can move on. Thank you.
Okay, so yeah, that's about maps and big maps. And if you want to define a map or a big map, then you can do them with these literal creators. We have the initial value, and then to assign a type to the keys, we use the T key field, and to assign a value, assign a type to the value, we use the T value field. So in here, it's a mapping from a NAT key to an address value. And finally, something really important on SmartPy, we also have the record type. Now, this record type can be thought of like JavaScript objects, where we can have multiple variables with multiple different types. So these are also key, basically key value pairs, but the keys are just aliases, and the values can be of any type we want. So in this case, the variable 1 is an alias and it has a type of nat. Variable 2 is another alias and it has a type of int. And the third one has a type of address. Now, another thing to note is that in Michelson, we do not have the record type. This is just a native to SmartPy. If you want to mimic records in Michelson, what you basically do is you chain a set of pairs. So in this case, you see we have one pair where the first type is nat, and the second type is another pair where the first type isn't and the second type is address. So here you can see we get a nat, we get an int, and we get an address, just like in the case of records, a nat and an int and an address. So this also answers the question that why don't we directly code in a more lower level language? And that is because of all this. We don't get such abstractions like records, and you will see there are several other abstractions that we don't end up getting if we code directly in a slightly lower language. And then there are some other types, like we have contract types to represent a contract instance. We have bytes types, string, bools. Sets are like JavaScript sets. And finally, a unit type, which just represents a unit value, like a scalar value with no other value attached to it. Now, for an exhaustive list, you can refer to SmartPy docs. They have a complete list of all the types and also some examples of using the types. So you can refer to the documentation. So let's get back to the contract and let's define a storage, a very basic storage. So the first field in the storage, let's call it num1, and we can give it the value of a nat. Let's say nat5. Now let's say we have another field called num2, and we can call it, we can give it a value, an integer value of, let's say, -2. Now let's have another field. Let's call it admin. Now, for the time being, I'm giving this an address field and just calling it TZ1. This is valid. It will compile down, but we will eventually have to change it, and I'll show to what value we eventually end up changing it. But for the time being, just keep it as sp.address. Maybe I'll give some spaces to make it more clear. Now let's make a timestamp and let's call it time. And that should be, we can give any nat literal here. Let's give maybe 25. And then let's have a map. Let's call it map1, which would be a simple map. The initial value would be an empty map. The key would be maybe of a nat type. And let's give it a value type of an address. Now I'll just copy it and create another map, but this time this would be a big map and not a standard mapping. And instead of map, I will call this big map. So there we have our small little storage. Now you could maybe just for experimenting, drop in some more values, but I'm just using the most commonly used types here. Now let's make an entry point. Just like I told you a few slides ago, to make an entry point, we use Python decorators. Now for this, you don't really have to know how decorators work. Like till this date, I don't really understand how decorators work properly. But the point is that they make the compiler understand that yes, it's not a normal Python function, rather it's an entry point. So let's call it something like change num values, because we will be changing the values of the numeric types here. Now, just like in a standard Python class, when we define a function, we use the self keyword, because to refer to the current instance, we write self here. And then we pass in a params, which would be the parameters. So now ideally, let's say if you're using something like TypeScript, then what do you usually do is that you put several parameters like this, like int a, and then you give it some type like number, and then maybe int b and give it another type number. But that doesn't work here. Here, what we have to do is you have to constrain the type of params or parameters. And how do we do that? We do that by writing sp.setType params, and then we constrain it using, if it has multiple values, in this case it will have multiple values, then what we do is we use a record. If it just has one value, then you can straightforward just add the type. Let's say if it was just an address, then we could have just written sp.t address and we were good to go. But since I will be putting multiple fields here, then we have to use a record. So let's say first field is num a, or first parameter is num a, and it would be of type nat. And the second parameter is num b, which would be of, let's say, type integer. So there you go. We have a simple entry point where we are taking in some parameters, two parameters to be specific, num a and num b, where num a is of type of type nat and num b is of type integer. So before going further, let's discuss some more topics. Are there any questions in the chat, Brian?
Yes. So I think there's a question. So there is a question on, is SmartPy equally as secure as Solidity? And what is the situation of storing data structures on the Tezos blockchain?
Could you
Is it
repeat?
like,
I didn't get the first part.
okay, this user is saying, is SmartPy equally secure as Solidity? And what is the situation of storing data structures on the Tezos blockchain? Is there like a memory of and storage in Solidity?
So yeah, it's Well, it's sort of similar to Solidity, but in Solidity, just like before writing the class, you have all these storage definitions. In the same way we have on Tezos, we have a storage definition, and then we have the functions that can change those storage definitions. So you can actually compare both of them. Can you repeat
Okay.
the first question? I still didn't get it. Like, how is it? How is SmartPy related to Solidity?
So he's saying, is SmartPy equally secure as Solidity and question mark.
Superior.
Secure, secure, secure.
I didn't get like
Like is it as secure as Solidity? Yeah,
maybe wait. Is the question here? Okay. Okay,
yeah.
secure as Solidity. Okay. So, well, I'm not sure like what do you mean by secure, because well, let's say in Tezos, we do not have we can't have something like reentrancy or like proper reentrancy as it works on Ethereum. And it's not a feature of SmartPy, and also on Ethereum, the reentrancy is not because Solidity is a weak language, but it is how the eventually the stack works under the hood. That is what matters here. So if the stack allows such insecure or like these bad operations to happen, then it's going to happen. It doesn't matter which language you are typing, which language you are using. So yeah, long story short, it doesn't depend on SmartPy. But on Tezos, there are most of the common security loopholes that exist on Ethereum. They don't exist on Tezos.
Okay. I think a lot of the viewers are requesting that you turn to dapp team. Is
I
it
tend to.
a lot of the users are asking you to change your team into the dapp team, which is the dapp background.
Okay, okay, yeah, because
Is
that
it
might be
possible to
of
do on
SmartPy, of the
yeah
SmartPy or of the slides.
the smart pie? Yeah, the smart pie.
Yeah, yeah, I can definitely do that.
Yeah,
Wait, I kind of forgot how to do that. Oh yeah, yeah,
yeah. Okay, thanks.
awesome.
You can continue on. There's no more uh, comments. Yep.
Okay, awesome. So now let's look into some arithmetic operations on SmartPy. So on SmartPy, arithmetic operations are strongly typed, and not just on SmartPy, but rather on Tezos itself. So the ones you see in green, all of them are possible. You can add a nat with a nat, and then you get another nat. If you divide a nat with a nat, you get a nat. So all those which you see in green, those are possible. The ones you see in yellow, they are possible, but you have to be really careful with them. So in the first case, when you subtract a nat from a nat, the result that you get is actually of an integer type. Now, why is it of integer type? So let's say you have 4 and 5. If you subtract 5 from 4, then you get -1, right? And -1 is not a nat, it's an integer. So just to be assured that we don't end up with some kind of an error, we use an integer type. And for mutez, mutez minus mutez will give you a mutez. But in the event that this is a negative number, then you will get an error, because there is no concept of negative currency, right? Like it always should be positive. So if ever you subtract a mutez from another mutez and you are getting a negative value, the execution will just stop there and the transaction will fail. Now the ones that you see in red, the first one is not possible. Now the second one is not possible in SmartPy right now, but you can actually do this in Michelson directly. This is possible in Michelson, but on SmartPy, they are working to insert special functions that eventually make arithmetic operations between nat and integer directly possible. But if you if you have like num a and num b in our example, and you try to add them or subtract one from the other, the op, the transaction will fail because it's not allowed in SmartPy yet. So just like in pure Python, we have conditionals. So in the first case, we are we are making some logical checks. And if it's correct, we are doing something else, we do something else. In a similar way, in SmartPy, we overload the if and else constructions. So if is loaded overloaded with sp.if, and we make our similar checks. To be noted that we don't use the and string, rather we use the and symbol, just one and, not two ands. And then we have a similar sp.else. Now, contract call specific properties. So if you're coming from an Ethereum background, you will understand this much better, but I'll try to explain to those who are completely new to smart contracts. So whenever you are making a call to a smart contract or calling a function, there are some properties that are available by default in that call. And these properties depend upon who is calling the function, the entry point in a particular smart contract, and what time they are calling it, which block they are calling it on. So the first two properties in Michelson, they are sender and source. And if you want to access them on SmartPy, we use sp.sender and sp.source. And both of them are of address types. Now, what do sender and source actually mean? So I've inserted a slide for that. So let's say we have a contract one and a contract two. Okay. And the user ends up calling contract one. Then in contract one, the source will be the user and the sender will also be the user. Very simple. But in contract two, the source will still be the user, because source actually gives you the initiator of the entire sequence of calls. So the source will be the user, but the sender will be contract one, because contract one is sending a transaction to contract two. So it's really intuitive to understand. For source, you will always get the initiator, but for sender, you will get the last address that sent the transaction. Apart from that, we have now. For now, basically gives you the current Unix timestamp, or the Unix timestamp of the current block, or technically the next block that is about to be formed. You get the timestamp of that. And then it's the level. Level is basically the block number. And finally, amount. So let's say if you're sending some amount of Tez when you're calling a particular entry point, then that amount can be accessed using sp.amount in SmartPy. And the equivalent Michelson is just the amount word. And it's of type sp.tmutez. Now, finally, we have something called assertions. Now, assertions are really important, and assertions basically give you a checking criteria. So let's say we define an integer variable x whose value is 4, and then we verify. And what sp.verify does is it checks whether this statement is true or not. If it is true, then the flow goes ahead. If it is false, then the flow stops there and then. So in this case, the first thing that we have to check is whether x is greater than 0. So it is verifying whether x is greater than 0. And in this case, it is greater than 0 because it is 4. So it's a check mark. The flow goes ahead. And if in the next case, it is verifying whether x is an odd number, because this is actually checking whether we are getting 1 if we are moduloing it with 2. So in this case, we won't get 1 because x is an even number, right? So we get 0, and the controls flow stops, and we never get to this statement. So one thing to note here is that the first parameter here in sp.verify is the condition that we have to check, and the second parameter is the message that you will send if the condition is not satisfied. So in the first case, if this was not satisfied, we would have sent x is negative, and in the second case, we will be sending x is even, right? Because we are expecting an odd number, and x is even is an error. Are there any questions? Because these were like quite a lot of concepts.
Okay, so a question from
Mhm.
a user is a viewer is that can't we use absolute value in net and mute test subtraction?
Can we use absolute values in NAT and mutez subtraction?
Yes,
So
question mark.
you mean we have a NAT and mutez? Brian, is it NAT and mutez?
Yes, it's a net and a mute
No,
test
you like
subtraction.
first you have to convert mutes to nat or nat to mutes. Both the types must, both the values or the operands must be of the same type. So on SmartPy, we actually have a function which can convert nat to mutes. So you actually have to use that first, and then you can proceed ahead. But like you can't do anything with one nat and mutes and then apply absolute. You can't really do that. The first step is wrong. Any other question? Brian? Any other question, Brian?
Oh,
You aren't
I
audible.
sorry, I think I was muted. So there is a question. If x is greater than it equal to 0, how will it be negative? Yeah.
Okay, so this is like a very common doubt. So just maybe just don't bother about the second part. Okay, just bother about the first part. It is verifying this statement. So think of this like, if this is true, then you go ahead, else you take this message and you put it further, because if this condition is not true, that means x is negative, right? Think of this as a contradiction check. If this is not true, then this is true, which is x is negative, right? That would make sense. It's a bit tricky to understand at the first glance, but as you keep using it, you will get a hang of it.
Okay, there's one last question. Is verify the same as assertions or some kind
Yes, it
of
is the
built-in
same.
unit test? Yeah.
Yeah, it's the same as assertions. Those who are coming from Solidity, on Solidity, we have require statements. It's the same. So it's just like require statements. In require statements, you give a positive check first, whether it's actually happening, and then you give an error message. So it's very similar to that.
Yeah. Okay. That's the last question. I think you can move on. Yeah.
Awesome. So let's go ahead and complete our contract. So now let's make some checks or assertions. Now, the first assertion that we will make is that we will check whether the sender, that is sp.sender, is actually the admin or not. Okay, so we do sp.verify sp.sender equals equals. And once again, this is a positive check. So we check whether sp.sender equals the admin. Now, to access any storage field in SmartPy, the way you do it is that you prepend self.data and then you write the name of the field. And this way you can access the field. So here sp.sender equals equals self.data.admin. And if that is not the case, then we give an error. Now, what will this error be? Well, we can just say not authorized. We are not authorized to make this call. Now let's try one more assertion. And in this case, let's try with sp.now. So basically, if we want this entry point to execute properly, the current block timestamp must be greater than the timestamp provided in the time field. So sp.now greater than self.data.time. And if it's not correct, then we can maybe write incorrect timing. So there we have a couple of assertions. Now let's do an assignment. For assignment or assigning a value to some field, we can do it in a similar way. We do self.data.num1 and then we assign any value we want. But in here, what we are going to do is we will assign the value num_a. So we do params.num_a. So we take num_a from params and we assign it to num1. So this is just like how it works in a normal programming language. It doesn't matter what alias we give here. As long as the types match, we can assign them to existing storage fields. Now in here you see num_a is of type nat and num1 is also of type nat, right? So this is correct. But if I make this num_b, this won't compile because num_b is of type integer and we are expecting a type nat for num_1. Now let's try a conditional. So for the conditionals, let's do something like this. For num_b, this is an integer, so this can either be a negative value or 0 or a positive value, right? So what we are going to do is we will take the absolute value of num_b and put it in num_2. And how do we do that? So we will check if params.num_b is greater than 0, that it is, if it is already positive, then well, you can just go ahead and put it in num_2. Right. Else, what you do is you multiply it by -1, because if you multiply, else means because it could be either 0 or a negative number, and if you multiply -1 with a negative number, you get the positive variant of that, right? num_b. So at the end, num_2 will have the absolute value of num_b, and we do this using a conditional. Any questions before we proceed to the next entry point?
Okay, so there's a question.
Hmm.
There is from a user. Is there no fallback function in SmartPy?
There is a fallback function, and that is actually written like this. It's called default. So you must write the word default, and then you can basically do anything within this fallback function. So if you're just sending Tez to a contract without calling any entry point, then the default function is called. So yeah, you can maybe, if you don't want anything in the default function or the fallback function, just write pass, and this will just accept Tez.
Yeah. Okay. I think that's the last of the question. Thank you.
Awesome. So now let's write another entry point. And in this one, what we are going to do is we'll change or insert values in the mappings. So let's call it change map values. And this time we will just take one parameter just to show you how one parameter would work. And to constrain the type, what we can do is sp.setType num, and we want num to be of a nat type. Now, how will we use this num? We will use this num as a key for our maps, for a map and our big map to be specific. So how do we assign a key value paired to a map? We do that using sp.data dot the name of the map, and in box brackets we give the key value. So in this case, the value is num, and then we give it some kind of a value. So in this case, the value must be of type address, right? So what we could do here is we could write sp.sender, because sp.sender is of type address, right? Now these obviously don't mean anything. I'm just playing around with types and showing you how it all fits together. And tomorrow when we write the lottery contract, it's all going to make much more sense. And in a similar way, just like we assign values in maps, we can do it for big maps. And let's assign a similar value, map to num equals sp.sender. It's literally the same. Maps and big maps are only different regarding how they work under the hood. From a top level view, you just interact with them in a very, very similar way. So that's our two entry points in our small contract. Now we have written the contract, but the next step would be to test out the contract, right? Because we still don't know whether everything actually works correctly. So to test out the contract, we can use the inbuilt testing module of SmartPy. And to utilize that, or to write specific unit tests, we use the sp.addTest decorator. And make sure you do it outside of your class. So don't put it within the class. We write sp.addTest. And then in the parentheses, we can give some kind of a name to the test. Now, just by my own convention, if I have one test, just one test, then I give it the name main. So because in this case, I'll just be writing one test. So why not just call it main? Then define a Python function. You can call it anything, but just for the sake of clarity, I call it test. And the first thing that you do within this testing function is that you define something called a SmartPy scenario or a SmartPy testing scenario. Now, this will basically simulate an actual transaction and then give you the results of the simulation. And then you can see this result of the simulation in the output panel later on when we compile the contract. Now, to interact with the contract, we will be needing test addresses, right? So if you're coming from an Ethereum background, you know, on Ethereum, we have tools like Ganache, and with Ganache, you get test uh, accounts out of the box. But on Tezos, we even go a step further and we have custom testing accounts that we can make within the contract itself. So in here, let's say testing accounts. And the first account, I want to call it Alice. And I make a testing account using sp.test account. And then within the parameters, I pass some string which can be anything. But it must be noted that this string is what is used to create this test account. So if I pass Alice here, I'll get some other test account. But if I pass something like Bob here, then I'll get another test account. So just remember that this is used to get the address of the entity that you will be using here. And let's say we have Bob, then Bob would be sp.test account, Bob, and we can even have an admin. I won't be using these many accounts. I'm just making them to show you that we can have as many accounts as we want. So now once we have the test account, let's go back to this. Here I've mentioned sp.address and tz1. Now let's say if I want to test out this entry point, then in this case, here the sender must be admin, right? So just so that all of it fits together, I will use this admin test account in here. So I'll copy this and I'll paste it here. And then I'll do dot address because this actually gives me a lot of things. It doesn't just give me the address, but rather some other stuff as well. And I just want the address out of the test account. That's why I append the dot address field here. Now, let's call the first entry point, which is change num values. But before calling that, we actually need to define an instance of this contract, right? Because if we don't have an instance, like what are we going to call? So for that, I'll say playground equals playground. And we have an instance of the contract. And this is one, the next step is really important. And most of the times, whenever I get an error in the contracts, it's usually because I end up missing this step. So remember, after you define an instance or create an instance, you have to insert it into a scenario by doing scenario plus equals playground. Because if you don't insert it within the scenarios and you try to call an entry point, it's going to show that you are making some calls which is outside the contract because you haven't even added it into the scenario. So these two, or the second step, is really important. Now let's call the change num entry point, change num values. But where are we calling it? We are calling it in the playground contract. So it's going to be playground dot change num values, and we'll pass in some values, which would be once again num a and num b. So num a, let's say for num a, I want a nat value of 2, and for num b, I want an integer value of, let's say, -3. Okay. Now, this is a very simple call, but in here I still need to define the values of sp.sender and sp.now. Because when you're making a call on the blockchain itself, then the baker who ends up baking your block, or in the software, these values are provided by default. So it happens automatically. But in the testing scenarios, we have to manually do that. And this is what provides us some true flexibility. So in this case, I append a dot run, and in this dot run, I can enter the properties which are call specific. So in here, we have two properties. We have the sender and we have the now property. So the first is the sender property, which will in this case be what? Be admin. Because if it's not the admin, if it's not the same address as this, it's gonna fail. So we will write sender as admin, and now should be a value greater than the timestamp. So this is 25. So in here, we must have something that is greater than 25. So, well, let's make it 26. And that's it. This is a simple call that gets loaded into the scenario. Now, when I click run, two things will happen. The first thing is that the contract will be compiled. And if there are some errors, then I'll get the errors. And the second thing that happens is that this entry point in the contract is called. So let's click on run. And I don't have any errors. But on the right hand panel, first you can see the initial values. So here you can see I have an admin. The maps are empty. Num1 is 5. Num2 is -2, just like we had it here. And the time is timestamp 25. So these are the initial values. Now if I scroll down, here I can see the transaction. The transaction where change num values entry point was called with these two parameters. And now if I see the storage, look carefully. Num1 has changed from 5 to 2 because I passed in 2 here, and this was a direct assignment. And in the second case, that is for num2, I passed in -3, but since we are using absolute values, we are just getting a 3 here. And timestamp continues to remain same. So that is how it works. Now let's also call change map values. Scenario plus equals playground, change map values. And then I will just be passing any number which will be like a key. So let's call it 5. And then remember that I have to pass the sender. So I'll again append run. And for sender, let's say this time I'll use Alice. If I click run, there is another transaction here. And as you can see, in map, we have the key and value pair. And the same goes for map 2, which is a big map. We have a key value pairs. So next I'll be showing you negative calls. But before that, are there any questions?
Okay, there is a question from a user. Why does console only shows the absolute value of variables?
Which one? Like in the case of num_b, I'm making it an absolute value. That's why it is showing. But which exact console are they talking about?
Yeah, I think they just a general. They didn't elaborate. Yeah, so that's the only question now. Perhaps he will come back with another question afterwards. Yeah, you can actually continue on. Just a question. This would be like the code will actually be shared right at the end of the workshop. Yeah,
Yeah,
because
actually, you can, if my screen is still visible, you can see that here I have attached the playground contract. So the entire contract is shared.
okay. Yeah,
Okay.
thank you.
Now, one final thing is that what if we want to test negative conditions? So let's say if we want to check whether this will actually fail or not, right? So to check that, what we can do is Let's copy this. But this time, instead of passing admin, I'll pass Alice. Now, if I pass Alice, obviously this check won't go through, right? Because this check is expecting an admin. And this admin has the test account that is created using the admin string. And this is not valid because in Alice, it is created using Alice. So if I call, I'll get an error. And that error is that, well, it's not authorized. Now, getting errors like this is not ideal. So what I really want to do is I want to tell the compiler or the test scenario that this transaction is not valid. And to do that, I can write valid equals false in run. Valid equals false. And now if I run it, I won't get an error, but here you can see it's a reverted transaction with the message not authorized. Now, if I want it to hit the second verification condition, well, let's copy it again. Let's paste it. And this time I will leave the sender as admin, but the now condition would be, let's make it 24, because here it must be greater than time, and time is 25. So we'll make it 24. And now if I run it, once again, we'll get an error, incorrect timing. So if I write valid equals false, run it again, and once again, no error this time, but there is a reverted transaction with the message incorrect timing. So these are some of the features that you will be using. Like 90% of the time you are coding a smart contract in SmartPy or Tezos in general. So I've attached the entire contract here, so you can go ahead and check this out. And the link is also here in the slides. So time for proper Q&A. If you have questions like from any slide throughout this presentation, just you can let me know right now. Brian, maybe you can tell me if some questions pop up.
Okay, yeah, sure. I have a question. What is the difference between Alice and the admin?
What is the difference between?
Alice and the admin. So it's a
Okay,
different account. Yeah.
okay. So see, Alice and admin, the difference is that let me do this. Let me console. Let me put it on the console. So here I can do something like, I guess it was scenario.show. If I write alice.address, and if I do admin.address, and if I run it, well, at the end, you'll see both of these addresses are different. So these are basically test addresses. And that is what I'm creating when I'm writing sp.test account. And if I remove dot address and just log the entire account, then you see it's a complete record. I have the address, I have the seed, which is the Alice keyword, and then I have other fields like public key, which I was talking about in yesterday's presentation, and then we have the secret key, which is like the private key. So we have several other fields, but we are just concerned with the address field. So that's why we append the dot address field to the test account. I think that should make your question and answer your question.
Okay, the next question would be, so are the test account properties predefined, and can we use customized properties for test account?
So they are not predefined, but rather they are created using the string that you place here. So wait, I'll show you. So let's say we have Alice here, and let's call it Alice, and the second one, let's call it John. But what we do is that I won't change the string literal. Okay, I won't change the string. I'm changing it to John here, but I'm keeping it to Alice. Okay. Now, if I show you both the test accounts, so let's say Alice and John, and both of them are same. You can see all the fields are same because the way the test account is generated is using the literal that you provide. So if you want to generate different accounts, you just provide different literals. So if you want to keep it all consistent, what you can do is just make Alice 1, Alice 2, and it will generate different accounts. So yeah, this you should understand with this.
Okay, one last question would be why do we need to use SmartPy and why don't we use the Python language directly?
Well, the reason is that if you use Python language directly, we can't really, what will we do with that? Because what SmartPy does is that it takes in the code that you write and then it gets converted to another high level language, because Michelson is not really assembly language, right? It's some other language. And with base level Python, that's really difficult to do. So you actually need to create this layer of abstraction on top of Python and then do that, and that is what SmartPy does.
Yeah, okay. I think that's the last question. I think there's actually one more. What if we
Mhm.
use the same string for two different users?
Well, I just showed that. So let's say in this case, I use same for Alice and John, then both of them will have the same fields. As you can see in the right hand panel, all the fields are same. So you can use either Alice. So in this case, let's say instead of Alice, I use John. It's still gonna work. It's still going to work because all the fields are same, because the string literal that is generating the account is the same.
Okay, I think that's all. Okay, I think there's actually another question. Can you
Yeah,
tell me
sure.
what are we supposed to make in this hackathon? Yeah.
Can I tell you what are you supposed to make? So, well, you're supposed to make a complete, well, you're expected to make a complete dapp that will have a smart contract which is deployed on a test net, and you have a front end which will interact with this contract. And if you follow all the three workshops that I will be giving, that is including today's workshop, I have two more, then we will be making a lottery application where there will be a front end and there will be a lottery contract that we deploy on the testnet, and we interact with that contract. You can actually play a game of simple lottery at the end of three workshops or three sessions. So you will get a complete hang of it by Saturday.
Okay, I think that's actually the last question. So, if anything else, we would like to end this workshop. But before we do that, just remember that for tomorrow it will actually be part two of this workshop at the same time. And I would like to thank Anshu for presenting this workshop. Okay, bye,
And one thing,
guys.
like if you guys have any question, just ping me on Discord. I'm available there. I'll answer all your questions.
Okay, thank you guys. Have a nice day. Bye bye.